Me and Moses will be doing a bit of collaboration here. So once I go offline, Moses will take over, but I'll be present partially, and I'll be when he calls on me, I'll be um assisting with the class as well. Okay, but let's go ahead. Okay. So welcome to today's class, guys. Today we are learning pandas. Yesterday we learned NumPy, and today we are learning pandas. All right. So pandas is a library, like was explained previously, the library which allows you to perform data analysis alongside with NumPy. Okay. So you can also research more about pandas. Please mute your mic. Let me do that for you. And don't disrupt our class. Thank you. Let me mute your mic. Okay. So first, when you are before you begin using pandas, make sure you have pandas installed on your PC. Okay. Now, if you're using Collab, you don't actually need to install it, but if you're using other files, other applications to run Python programs, you should try to install it. Now, how do you install pandas? By calling the command quote pip install pandas. This command. Let me unquote it for you. See this command, exclamation mark pip install pandas. This this one you are seeing, this command you are calling hello.py, this exclamation pip is a command that tells your compiler to go to pip Python library and install pandas from there. Okay, so these are you install pandas firstly if you don't have pandas. So the next thing, you can load your data from various sources. You can load from Excel file. Now, if you're loading for Excel file, you use the pd.read underscore Excel file. PD means pandas, okay? It means pandas for short. Same way we imported numpy as NP, we import pandas as PD. So pd.read underscore Excel file. So you see this Excel file. Yes, it's there. Specified. Then you call the file, and the extension should be .xlsx. This is the extension for Excel file. Then for a JSON file, you use the .read underscore JSON, then the extension for a JSON file, JavaScript file. Then CSV file, same thing, read underscore CSV, then the extension .csv file. So before you read the file, always check the extension of the file you are reading so you know the commands to call. All right, so let's move ahead. Now, before you use pandas, you're going to import pandas, import the library, import the necessary library you need. So we have the import pandas as PD. That's why you're seeing PD here. So we imported pandas as PD. Then also, yeah, I imported warnings. Warnings, yeah, I imported warnings. I did put an alias, so I said warnings. This is a library as well, so which allows me to tell the compiler to ignore some warnings when it's coming up. When any warning is coming up, ignore it. All right. So that's the essence of this method, import warnings. Okay, you can exclude it from your code. It is not necessarily needed, or depend on what you are performing. All right. So let's load data from a dictionary. Now, in our classes, we'll be told that a dictionary is the bedrock of every data that has been collated. That's why I call it the baba of all the data structure, because everything we have that involves data are collated in a dictionary format. Whether it's a nested dictionary, whatever, they are all in dictionary format. Okay, because it has key and value pair. That's why we use it. So that's why you see I'm creating a dictionary now. So yeah, I'm creating it. So I called it data. Data is equals to, open my curly brace. Then I called my column. Now watch what I'm doing. I called my key. I put my colon. Then my value, now I passed a list. Please make sure you are typing this or writing it somewhere or screenshotting, as the case may be. So I typed all these. These are the different keys, different values assigned to this key. So in order for me to get these names, I need to call the key. So that's why I passed a list inside. You can even pass a tuple here. Take for example, there's password. You can pass it as a tuple too. Then I declared another key age and gave it values. Now the values I'm giving are corresponding to the values you see here, the numbers of values in each key. So then the next one was city, and I called it, passed in a list as the values. Then the last was salary, and I passed in 5 different salary ranges. Okay, then I close my bracket and I run it. All right, so I've loaded my data. Okay, let me clear our attributes. So let me clear our attributes. So I can do that and run it again for everybody to see. All right, so the next thing now is for you to create a data frame. All right. Now, when you've loaded, when you've like here now, I created a dictionary and I want to make it a data frame. All right. I'm converting as a data frame. Now, if you load your, look at this, if you load this file now, here, any of your Excel file or JSON file or CSV file, when you load it using the pd.read, it reads this file and loads it as a data frame automatically. But here I'm making a data frame from a dictionary. Hence the title, make a data frame from a dictionary. Okay, so I'm just creating my own data frame. So after creating a dictionary, then I'm converting it to from an ordinary dictionary to a data frame. Okay, so that's why I use the df is equals to pd dot data frame data. Then I pass in the name of my dictionary here, data. So pd dot data frame. Then I pass the name of my dictionary data. All right. So running this, it has worked. Then I can decide to view it. Now let me view it here. Let me view it. So I view it by calling df. I don't use print. I view it by calling df. Now look at a data frame. This is how a data frame is structured. Look at it. This is how a data frame is structured. So these are the keys, name. These are the values I specified. This is age, is value. City is value. Salary is value. This is how a data frame is specified. So if you are reading your file and it does not look like this, that means there's a problem somewhere. All right, there's a problem somewhere. Now, when it looks like this, you see these 3 symbols: your interactive table, suggesting charts, and automatically generating codes. You see these icons here by the side of your data frame. Now, the difference why I didn't use print. So why did you use print? Because this is a data frame. Data frame does not require you using print, because print, when you use print on a data frame, we are calling the old data frame. When you use print, it changes it from a data frame, changes from a data frame to this. Okay, changes from a data frame format looking like this. Just values arranged. Okay, it's printing it without the frame itself. And if you look at this data frame, this is the original one. Let me clean this back. it looks formatted like your tables in Excel. Your tables in Excel. When you create a table in Excel, it looks like this. You see these different ranges of colors, different sections. You see them highlighted of color will be given to them in Excel automatically. So this is how the data frame looks like. It's in the form of a table with rows and columns. All right. So next you can select rows and columns in your data set, your data frame. Now we use the .head, which is a method in Pandas. .head, without specifying anything, we give you, if you're working with a column that has a data frame that has lengthy rows, .head will give you the first five. Okay, .head gives you the first five from 0 to 4. Gives you the first five. All right, so that's what .head does. I know I don't have much. This is just the length of my data set, 0 to 4. So that's why you're seeing it. So you can say .head and you specify the number. Let's say I want just 2. I want 2. That means give me using the indexing from 0 to 1. So you see, I just need 2. So you can specify. Then it gives you what you want. So as you can see, I used 2 and I'm getting just the first and the second information on my data set. All right. Can you guys hear me now? Hello, can you hear me? Can you guys hear me? People are not responding. No. So guys, can you hear me now? All right. So I had to join into another device. Um, Moses, can you share your screen from where I stopped, please? Yeah, sorry. Mr. Moses, can you share your screen for us to see? Sorry, guys, I had to stop sharing my screen. Oh, okay. Sorry. Let me put on the permission. Please check again if you can do that. Please mute your mic, everybody. All right, Moses, share your screen now. Let's see. Please scroll down to where I stopped. So we'll be using your screen to continue the class, but you have to be a bit fast with me while I'm moving forward. All right, thank you. So guys, I hope you all are following with the class. I hope you are following with the class. Okay, let's move ahead. So when I use df.head, as you can see, I specified my length. I want to see two values. I said, okay, give me two values. So you the dot head without any parameters passed in the bracket gets the first five, no matter how long your informations are on your data frame. It gets you the first five, 0 to 4 with the index, because you can see 0, 1 beside it are just the index attached to your data frame. Okay. So you can say, okay, maybe I want the first 50, the first 20. You can specify that. So when we are working with a large data set, we'll get to explore most of those opportunities. So please scroll up to the next one. Now you can select a single column. You can select a single column also. But in order for you to select a single column from a data frame, you have to do what we call indexing. Now, I told you that indexing in dictionary is you don't index by number, but you index by key, which gets you the value. So that's why we emphasize on that, because it is only with that you can index a data frame, okay, or any data. You must index and call the key. Please, can you guys see is please run your code. No, don't run all. Don't run all. Please don't run all. Just run from pandas. Run from pandas. Just be clicking them one by one. Load the data, please. Please, I hope you guys can see the screen.
Yes, sir, we can see the screen.
Thank you very much. So, guys, if at any time in point you get these error messages you are getting, please go and rerun your code, because check if at any point in time you disconnected from the runtime and you connected back. Because when you disconnect and you connect back, it's going to make all your processes not functioning unless you run them again. You can run all when you do click on you go to runtime, you click on run, or you run on from beginning to ending. All right, you can do that, or you can even say run from selected cell from where you are, just run from there to the bottom. You can do that as well. So you need to do that. So you can select a single column. So yeah, we've gotten the name. We can say, okay, let's get the age. So let's change the name and let's get the age, or should we say salary? Let's get the age. So we'll call the column name. And please note that whichever column name you are calling, it must be the way you wrote it. Oh. Python is case sensitive. Don't ever forget it. Your column name is a small letter. I beg, call it a small letters. If you call them a big letter, you're on your own. Oh. You will get errors you might not be able to solve. You see name error. Oh, key was not declared or was not found because you specified the wrong name. So always check out those things. All right. So as you can see, you can select the age, all right? You can select any column individually to see the informations from your data frame. Also, you can select multiple columns. You can select multiple columns. Now, how do you select multiple columns? In the first one, we used one bracket as an index. I know I explained this very well when we were doing data structures, how to index multiple items. Now, when you are indexing, you can slice, you can do whatever. Even here, you can also slice. But how do you select multiple columns? In the first one that is selected single column, watch the bracket. The square bracket was just one. But in this one, we are selecting multiple columns. The square bracket is double. Why is it double? It is double because you see the outer bracket is the index bracket. Then the inner bracket carries your two keys you want to select and makes them one inside the outer bracket. All right, so it combines them and brings them out for you. Even here, you can select more than one. All right, so let's run it. So as you can see, we selected the name and the age. So let's add the salary of this person. Let's add the salary. So we'll put a comma after the age, then a colon, a quote, then a salary, capital letter SALRY. So salary. Let's run it. As you can see, we can select more than two. All right. So that's how you select multiple columns and single columns when you want to view your data set. So let's move forward. Now, also, you can index by using the .loc method. Loc means locate. Okay. LOC means locate. So we are just telling the program, go and locate this information. Now, as you can see from the first one, this is just in a slicing without specifying a start and an end point. So let's run it. Let's run the loc df.loc. Now, as you can see, it selected everything because there's no beginning, there's no end. We're just telling it, give us everything. All right. So if you want to slice, you use the .loc. We also have .iloc, but let's understand this first. So .loc. So let's scroll down. Now, I want to slice now. All right. Now, the next line of code says df.loc. Then you are seeing a slicer there with a comma. I already explained what this means when I was teaching NumPy, the previous class. I already explained why we have a comma there. Now, you are seeing this comma, then you are seeing name, and you are seeing city. All right? You are seeing name sliced by name and city. Now, what we are telling the compiler to do is that get me all the information. When I mean all the information from 0 to 4, get me all the information on my data frame, but I just need the name and their city. I need their name and their city, but I need everybody on that list, everybody on that data frame, everybody on that table. I need all of them, but I need just the name and their city. Don't forget that there's age, there's salary. So I need just the name and the city. So let's run it. That's what we're telling it to do. So as you can see, it gives me it gives me 0, name, and city. Now some of you are saying, sir, there's age there. Why is there age? Don't forget the rule of slicing. Your start point to your end point. So you are telling it, give me from name to what? City. Not name, only name and city, because this is slicing. Slicing gives you the name, that is from your start point to the end point. The first one we are seeing that does not have any parameter passed in the slicing with a comma. It means get me on the information of 0 to 4. All right. So that's how you slice in your data frame using the .loc method. Now we have the .iloc. Now the .iloc performs similar operations with the .loc, but the difference is that iloc works with integers, works with index number. All right, it works with index number. Sorry. Now the loc works with key and value, but the iloc, the I there means index. Iloc means use the index to locate it. So the first one, df.iloc, works exactly the way the df.loc works. So if we run it, it's going to give us every information. It's giving us all the information. All right. Now, the df.iloc, the same thing we passed in that first one when we used the give me all from name to name, age to country. That's what I want. So now we are telling it that use the iloc method, get me the information from 0 to 4, but start at index 2 and end at index 4. So let's run it. So you will see that some items won't be listed. As you can see now, there's no name, there's no age, but we are only seeing city and salary because of the index number we specified. Because of the index number we specified. So you should know the difference when you are calling this. All right? You should know the difference when you are calling this. Now, let's put, before somebody asks me the question, hold on. Let's put, in this iloc now, let's go and put the key name. Let's put the key name. Let's put city there where we have to. Let's put city. Don't forget our quote, please. Please don't forget our quote. Otherwise, we are going to see city is not defined. So let's not forget our quote. And then let's put salary. Let's put salary there. Yeah, let's run it. As you can see, we're having error. Hold on, let's see the error. It says type error. Scroll down, please. Type error. Cannot do positional index on indexes. Cannot do positional indexing on index with these indexers. City and the indexing is many. Listen, let me break it down. It's simply telling you that I cannot use index number with this index that you are giving me, city and whatever, because it's a string. You see why the iloc works with only numbers, but the loc works with strings. That's the key. So you can decide to go to the loc, go and put numbers and see what you will get. So let's revert, let's do what we just did. So Ctrl Z it, click on the cell and Ctrl Z. Just click on the cell, click on it. You have not clicked on it to my hand, so Ctrl Z, then it's going to go back to its original position. So you can play around, run it again. So you can play around with the previous one and test the difference for you. So let's move now. Now, okay. So also, another thing you can do with pandas is that you can set, reset, and use your indexes the way you like. What I mean by set, you can now when you read your data frame, when you read your data, your large data set or any data frame you are reading, when you read it inside with your pandas, it gives it an index number. Same way when you're using your Excel, you will see, or your Excel sheet, you see 0, you see 1 to the last value of Excel, you see ABCD that is used to identify this. So automatically it creates this indexing for you, 0 to whatever number you have or length of number you have on your data frame. It creates it for you. But you can reset the index by removing that 0 and the likes because you don't need them. If you don't need them, you can remove them. You can strip them off. All right? You can strip them off. Please, if you are not seeing this screen, please, you can log out, log in, or try and refresh on network, okay? So now, how do you set an index? You call the .set underscore index. As you can see, Python is all about just English language, very easy. DF, don't forget DF is the name of our data frame. When we did the reading and we did the conversion, we assigned everything we did to DF. So DF is the name of our data frame. So DF.set underscore index, that's the method you call in pandas. Then in the bracket, you specify what you want to use as the index. Either you want to use the name, the age, the country, or the salary. Your choice, pending what you want, how you want it to look like, your own taste. All right. So we want to use the name. So that's why you see df.set underscore index. Then in the bracket, I put my key name, which I want to use, name inside with quotes. Don't forget, Python is case sensitive, so you must always know what you used. All right, so let's run that. Now, when you run it, as you can see, it has run. Watch now, we're having name now. Where we had 0, 1, 2, 3, we're not seeing name, age, city, salary. There's no 0, 1, 2, 3 anymore because name is now our index number. That's why I see the name are now bold. All right, so that's how you set your index. So let's move down. Good. Now, okay. Now you can also set an index. Now, the first one we set the index on the original data set. Now you can also set your index without you modifying the original data frame. All right. How do you set? Like I explained in NumPy, you can perform any action you want to perform on your original information or data, but you can assign the result to a new variable so that your original data will still remain the way it was. This is the same thing we did here. That's why you see we said new df is equals to df.setIndex, set_index, then name, so that our original information, the df, will not be changed. All right, so let's run this. So when we call the new df now, call the new df. So this is the new df. Now let's go back up, please. Scroll back up to before we did that set index. Scroll back up. All right, so no, not here. I wanted to call. Let's move forward. I wanted to call the df and show them something, but let's move forward. Don't worry. Scroll back down. Yeah, scroll back down. All right, so as you can see, we call the new df. It also has the all information. Also, please, when you are working with a data set, the first thing you should do is to copy it. Create a copy. It's the best practice to do. Create a copy of your data, because when you are giving an organizational data, it's best advised not to tamper with it. You are only given to work with. Now, how do you work without you not tampering with the company's information? Is by you creating a copy for yourself. You're creating a copy for yourself. Now, how do you create a copy? You call a new variable name, then assign that variable you've already read. Let me see, you read df. I don't know if we can show them. Scroll down, let's show them something. Let's say, let's scroll back to where we have df. Let's go to the beginning of our code. Go to the beginning of our code, please. Beginning of our code. Beginning, where we converted our data to a data frame. Yes, no, go up again. Go up again. Yes, run df, rerun this df, reload this and reload the creating data frame. Scroll down. Yes, run the no, you've passed it. 4. No, not that one. Yes, this one. Creating the data frame. Run it again. Good. So run this one. This df now. All right. So scroll down to where we did that new df. Let's do a copy for them. So you guys will understand it is essential you copy whatever you want to copy before you start modifying, because I know now we have been modifying, but scroll up. So now we have been modifying. So I want you, before you do anything, scroll up. You can do a copy. All right. So now bring this between now. Yeah, let's create a new cell. Let's do a copy for them. Let's do a copy. Let's copy the data set. No, you've gone back now. So Moses, you've gone back, please scroll down. Always select the cell you want to create a copy under. Otherwise, you go back to the where you last selected a cell. That's how Colab works. All right. So just click on and then create a new code. Now let's new df. Let's say new df, new df, new df1, new underscore df1, df1 1 is equal to df.copy dot copy. Now we already know what dot copy does. So put a parenthesis. The parenthesis must be accompanied with it. Round bracket, I mean. So run it. Okay, so as you can see, we have created a copy. Now call new df1. Call new df1. Create a new cell and call new df1. New df1. So as you can see, new df1 has all the information in our df. All right, so now let's go and reset this index. So as you can see, when we reset this index, it does not affect original df. So it is essential you always create a copy of every information you want to work with. So your original df is still there intact. So when we reset this index, and we give name as the index, nothing will change. Okay, so let's go and set the index. Create a new cell. Create a new cell. Yes. So let's set the index. Let's do new df1 dot set underscore index. Then we pass in the parameter, the key we want to use as an index. New df1 dot set index. I'm literally calling it out for you. New df1 dot set index, please. Please avoid doing lots of copy and pasting. When you type, the compiler has IntelliSense, so it automatically shows you what you want to do. When it just sees, oh, you are performing a series of operations. Please, I don't want to create new df is equals to new df. I said new df1 dot set index. Remove the first one you're writing there. That's why I said avoid copying a lot of information, please. Avoid copying a lot of information. So it's good you type. You get familiarized when you are typing. So when you just type new df1 dot set index, the program will just bring out some lists. Okay, just show you what you want to do. Just press tab and you get it gives you everything. So let's run this. Guys, are we still together on this class? Can you hear me? So as you can see, the index has been reset. I hope you all can hear me. Somebody's telling me no. So please always work on your network. So as you can see, the index has been reset. So we are not working with that frame again. We're working with the new df1 now from henceforth. So let's move down. Now, after setting your index, you can also use the in place method. Now, where you see this df now, Moses just put new underscore df1 on that set, on that part. We are not using df again. So just use new df underscore index1, new underscore df1. As you can see, this is what I said. When you type, IntelliSense gives you an information to pick on. I said pick from the information. I have not picked from it. No. I said new df1. Yeah, using new df1, please. That's what we're working with. Now, you can set the index and do in place equals to true. Now run it. Let us see what in place does. Good. Now, call your new df again. New df1, please. Call new df1. Now, as you can see, you can select from everything here. So let's recall it again. All right. So this is how you use the in place and use the without this putting the set index. So people can set in place equals to false. Put in place equals to false. Let's see. So let's run this. So as you can see now, okay, in place equals to false. None of the missing columns are in, okay. None of name are in the columns. None of name. The error. Please go back and run your new df1, please. Sorry. Don't worry. I understand. Don't worry. Don't worry. Yes, because you already made it the key. That's why we're having the key error. You already made it the key. We already made it the key. We already made the key, so don't worry. We'll try that on another we already made, just leave it as true. So you can use the implicit equals to true. We already made it the key. So that's why it's telling us it is not in it because it is already the key. All right. Please go back and run your. It's already the key. It's already the key. It's already the key. So it's not going to run. So unless you go back and run your new df1 from the beginning, of where we created where we did the dot copy or whatever. That's where you can get this because we already made it the key. That's why we're having this in place. Yes, just run on your df1 here. So just go down and do the in place again. Yes, run this one again. No, don't worry about the first. Just run this one. Let's not prolong the class. Click on this. So you can try because we already made it the key. Now this in place we did now made it the key permanent. All right. So because we already made it the key, that's why when we tried the false, it was showing us key error. We tried the true again, it was showing us key error because it's already the key. Okay, that's how we're getting that. So always understand the line of code. So let's move down. Now you can decide to reset the index back to, as you can see, this way in place gives you much more convenience. Now we made the index permanent by using the in place. So we want to reset it now back to its original. So put new df1, reset index, reset underscore index, then in place equals to true. That means reset it back to its normal position and then make it just permanent there. So when you run this, it's going to revert it back to the original. So if you go up and call your df now, if you call your df, you just call it here. If you call your df1 now, if you call your new df1 now, press tab. Come here. So if you call your df1 now, as you can see, it will be reverted back. It has reverted back to the way it was. That's how you reset your index and you set your index. So let's scroll down. Let's move forward. So the next thing you can do on your data frame, you can include filters. Okay. Now, how do you filter? You introduce relational operators on it, like we did in NumPy in the last class. You can include a relational operator by specifying what you want to use to filter it. Now, we want to select some rows. What I want to filter. I want to filter the rows. Filter it. Now, as you can see, I said df. Now, what I did here was I said df, which is the name of my data frame. df. Now in the indexing bracket, which is the square bracket, that's where I put my condition, my filter. That's why you're seeing another df with a age greater than 25. So I'm telling the compiler, give me all the informations that have an age greater than 25. So let's run it. Don't need to change it, but you don't need to change it. Don't need to change it. Don't change it because you end up changing. It'll take more time. So don't change it. You still get the information you want. So just run it. So as you can see, it's giving me just the information we have that meets our criteria, that is greater than 25. That's why the index number is 1, 3, and 4. That means only Bob, David, and Emma has age greater than 25. So these are your filter. Now, this is one condition. Then the next one, you can filter based on multiple conditions. We also tried that in NumPy also. Now, if you are filtering based on multiple conditions, that's when you now include the AND operator. Okay, you must include the AND operator by specifying your two conditions. That's how you combine your two conditions. So that's why I said DF, which is the original data frame. Now I call my indexing bracket. Then inside my indexing bracket, that's why I'm putting my filters. Now my filter is also like an index, but now as you can see, because I'm using multiple conditions, I'm closing them in parentheses, in brackets, round brackets. So I'm calling the first condition df age. So I need, first of all, I need the information where the age is greater than 25 and they have salary that is less than 7,000. I need people that their age is 25. Take for example, they ask you, oh, please, I want to see those who are earning less than 75,000 naira in this company because I want to increment their salary. I want to see how they with those names. You can specify these conditions. So because okay, you can decide to get their name, get their information, where they are, no. So you now specify their age. Oh, I want an age bracket. I want an age bracket, or I want this bracket. You want to use some. You must specify what you want to use as your condition, your first condition to your second condition. Okay, so here now I'm saying people that are older than 25, which I know, yes, these people are parents, they are married or they have more responsibilities, they are no longer kids, but I need to increase their salary. So that's why you're seeing getting me the information where age is greater than 25 and the salary is less than 70,000. So let's run it. So as you can see, hello, as you can see, because of the two conditions given, none is met. None is met because anybody whose age is greater than 25, they are already earning from 70,000 and above. That's what we saw here. Now let's change the age. Let's put let's say less than 25. Let's put less than 25. Yes, let's list less than 25. Let's not change the age bracket. Less than 25. So let's run it again. Now we have some information. Now we can see only Charlie is 22 years old and is earning 55,000 naira. So you can decide to increase the salary, or I've got only one person. You can say, okay, let's see the one that is equal to 25 years old. Let's see if we have anybody in that list. I doubt we do, but let's check. So let's do the equal relational operator equal to. You're going to get an error now. That's not the relational operator. Thank you. Relational operator. Yeah. So let's go. Now we said equal to 25 and any less than 70,000. So as you can see, only Alice is 25 years old and earns less than 70K. So we can decide to increase the salary of the person. Okay. So this is where multiple condition comes in. All right. So let's move forward. Now, let's say we've gotten this information and want to like update it. We want to increase the salary and save it. How do we do it? brings us down to updating rows and columns. Now, this is all about modifying data within data frames. Now, I want to modify the new one we copied. So I'll be using new underscore df1 all through. So the first one now is, now we want to update an entire column. I want to update an entire column. Now, how am I going to do this? I'll call the index name. So I will assign this mean like assigning a variable, assigning values, changing values in one variable, using one variable name to two times. Now, you know, when we are learning variable, we told you that when you declare one variable multiple times with different values, the last one that was created becomes the new value of the variable because the variable names are the same. Right? So that's why you're seeing df age, that's an index, is equals to df age. Then I multiplied by 2. So what I'm simply telling the program is that you see the column age, get the column age and multiply all the values by 2 and assign it back to the column age. So I'm telling to replace the values by myself. So that's why you say I'm reassigning it. So let's run it. I said we should use the new DF. You have already changed my DF now. Yeah. Anyway, let's continue. So we have changed it. Now let's go and view it. Call DF for us, please. Call DF for us. So as you can see now, we've changed their age. I multiply their age by 2. Yeah. So please and please, I don't want to change my DF. Go back to where we created DF and run DF from the beginning. Yeah, you will stress ourselves in class today. Then I said, let's work with the copied one. Let's work with the copied one. So move to the beginning where we created this DF and do it again for me. Thank you. You have passed it. So just run. No, don't run that one. No, you can just run this DF. Yeah. You can just run this DF. So scroll back to where we are now. So run this DF, run this one. Yeah. So it has changed back. So guys, that's how you go and change your information. So if you made a mistake by changing the original one, please go back to the beginning of your code and rerun it from where you or read the file so that it will go back to the normal one. And always make sure you are working with the copy, because I want us to understand how working with copies works, because my next class will be analyzing a real-time data set. So get it and forward it to the class and then we'll move on. So run this. Then call new DF1. So new DF1, let's see. Good. So we see we've changed it. We've changed all the age, all right? We've multiplied it by. That's how you update. You can manipulate this. Let's say even if you want to update that person's salary now that was 25 years old and is earning less than 70,000, you can do it the same way, all right? By reassigning new values to it, or you will add values, your choice. So let's move down. Now, the next thing is that you can update a specific cell. I mean, a specific information, not the entire row or the entire values in that row, but maybe one person's row. Let's say you want to update this person's salary or whatever. Just that person, not the entire one. How do you do? You need to call where the salary is and do it. Now, for this one, I want to update the age. All right. So I'll tell the compiler to go to, as you can see, I'm using the .at. So put in new df1, please. Don't forget, it's new df1 we're working with. New df1. Now, the dot at method is like the dot locate, but the dot at simply tells the program that go to new df1, then at index 1, the age. Now, as you are seeing, I'm calling the index number, then I'm calling the column which I want to update. Now, I'm telling the program that go to index 1, go to its age, and assign 32 to the age. So run this code for us, please. So let's run it. Now it has run. So scroll up, call our new df1. Just call, go up, no, go up, go back, just run our new df1. As you can see, Bob is now 32 because Bob has the index number 1. All right, so that's how you update a specific item, a specific value, not the entire one. So scroll down, let's do the next one. So the next one is now locate. So the at and the locate works the same way. So either use the dot at or use the dot locate. It's the same thing. So this one is where at 1, then the other one is go and locate index 2 and update the age so to 48. So run it and let's go back to run our new df1. So let's scroll up and run our new df1. So as you can see, we've changed Bob and Charlie's age from 32 to 32 and 48. All right. So that's how you update individual values in your data frame. So let's move down. All right. So the next thing we can do, you can add and remove rows and columns from your data set. Let's say you have a column you don't need, or you want to add new columns that you want, you can do that. All right, you can do that. Now, how do you add a column? Please, new df, use the new df one, please. So how do you add a column? You're going to add a column. You don't necessarily need to change this one sharp because we already have them, but change it. You can add a column by doing some operations, by specifying some operations or some calculations. But how do you add a column? You must call the data frame which you want to put the column. Then in the indexing, in the index place where you are supposed to like call the column you want to update or whatever, you put in a new name that is not existing. You put a new name that has not been existent in that data frame. When the compiler sees that new name, it knows you are telling it to create it. Then after creating it, you now put, that's why you see the assignment operator there equal to. You now tell it that put this value for us. All right, put this value all true. So here now I'm telling it to create a new column called new column. Then do an operation by concatenating age and salary. This concatenation is not sum, please. Like I told you guys, it's not sum, it's concatenation because age here is an index number. So it's like we are indexing a string. So we are adding a string to a string. All right. So that's why you are seeing this information, and this is not sum. So we are telling you that take age and concatenate it with salary. So it's going to take every values of age and put every values of salary behind it, right? And add it to it. So let's run it. Good. So let's call our new df1. So let's see the output. Now, as you can see, it added from 60,000, it added 50. So you're not seeing 60,000, 50, 32. You're not seeing 80,032. So it has to be adding the values at the end of this thing. Okay, it's adding the values at the end of it. All right. So these are, as you can see, the new column has been created with the addition of the salary and the age. All right. So that's what you are seeing here. Okay. So let's move down. Then you can decide to remove a column. Let's say you have an unwanted column. You have an unwanted column. So you can remove a column if you don't want. So how do you remove? Use the dot drop. Df dot drop. Then you specify the column you want to remove. Okay, please don't do df.drop and you leave it blank. You can try it. When you try it, give me the feedback. So new underscore df1 dot drop. Then we said column is equal to the column name we want to drop. So let's run it. As you can see, we've dropped the new column we added, so it is now like the original without any issues on it. All right, guys. So that's how you drop a column. So let's move ahead. Now, how can you add? Now we add a row. We added a column and removed the column. So let's add a new row and let's remove the row. Now to add a new row, now a new row. Sorry. To add a new row now, you are passing information. Okay. Now this is what I did now. This new row I want to add now. First of all, I had to create it as a data frame first. I had to create it as a data frame. Now the row I'm adding, I want to add in all the information because what you are adding must have the same similar length of information on your original data frame. The same similar length of information. I didn't mean the number of rows, but the number of information because informations are assigned to a particular index row-wise. So that means from name, age, country, city, salary, you must have the same number of specified items. That's why, as you can see here now, I created a data frame called new row by using pd.dataframe. Then the bracket I specified my dictionary. I could have you can also create this the same way we created the data in the first place by assigning create a dictionary called data and then converting it to a data frame by using pd.dataframe, put the data inside and call a new name. So you can append a data frame to a data frame. Okay, that's how you add a row. Now this is the row I want to add. Now I said new row, new underscore row is equals to pd.dataframe. Then I created my data frame, name Frank, age 40. As you can see, these are all specified as list. Look at the square bracket too. Don't see I didn't omit it. It is there. Name Frank, age 40, city Seattle, salary is there. This scroll to where is salary. And let's see the salary. Salary is what? 90,000. Now all these things, all these values are specified in a list because our initial data set was passed like a list. The values were passed like a list. So when you now add this, it becomes it will be included in the original data set in each individual key. Now run it. Let's run it. So we've successfully created it. Now the next thing I'm going to do is to pass it inside. So I'm going to use pass it in our new df1. So I'm passing it in a new df1. Now I'm using the .concat. Now when we are adding a string to a string, we use the plus. Okay, it has the string. Maybe you're adding your surname to your name. Use the plus sign to concat it. But when you want to include an entire row, you don't use plus sign. There's a method called .concat in pandas. So that's why we said pd.concat. Same way we have a data frame, a method called the dataframe in pandas, which converts a dictionary to a data frame. We also have .concat, which is used to add or append new rows. This is how you append new rows. The append, we add the normal data structures is not the same here, please. This is .concat I use. So that's why we are saying .concat df comma. So please put new df there inside a bracket, please. It's new df are working, not df. New underscore df1. Good. Now we said concat, that is add new underscore df1 comma and new row which we created. That is, we are putting it in square bracket, like index. Then we said ignore index. We are telling you to ignore index. That's why we said ignore index is equals to true. Ignore index, because this new row has its own index. The new df1 has its own index. So we are telling you to ignore the index. All right, so that it won't cause problem. So we are saying ignore the index. So then we said axis is equals to 0. Now let's run it. And everything we did, we assigned it to back to new df. So we are replacing the original one. So it has run. Now let's call our new df. Let's call our new df and see our new row we've added. New df1. So scroll down, please. So as you can see, it added Frank 40, Seattle 90, NAN. Now, do you know why we are seeing NAN here? Because our new column, which we created, we did not specify the length here. So scroll up, scroll up. So as you can see now, wait here. As you can see now, here now, we did not specify it. That's why we are seeing NAN. We didn't specify it. That's why we are seeing NAN. Okay, that's why you are seeing any in there, because we didn't specify anything. You did not specify. If you not specify the exact length of your data frame, you won't, it will be showing any end there. So scroll up, and we can decide to drop it as well. Scroll down, sorry, scroll back down. So that's how you add new rows. Please, you must also know how your information is, the length of your information when you are adding this, so that you won't be seeing missing values. Any end means missing information there. So you can drop a row. So you are seeing new df1 dot drop, then we are putting the index number. Hold on, we are putting the index number to drop. Now here was 0, but I don't want it to drop 0, so I want it to drop the one we just added. So put 5 there. So drop 5, that means you drop the index 5. So run it. So as you can see, it has dropped it. Scroll down, please. As you can see, it is no longer there. All right, it's no longer there. So that's how you add, that's how you remove. Okay, so scroll, let's continue. Then you can sort your data. Yes, you can sort your data by using the sorts. I know I thought this, but let's proceed. You can sort your data in your data frame, either in ascending order or in descending order. Okay, you can sort it. So please fill your attendance, guys. It's already pinned in the chat, so go and fill it up. So how do you sort? Now you can sort. We have the dot sort method. We have the dot sort values method. Okay, we have the dot sort method and we have the dot sort values method. Let's do the dot sort first. Please create a new cell. No, let's do this one, then we create a new cell under. Now the dot sort method sorts automatically. You don't need to specify anything. It sorts the data set by itself, sort in ascending order by itself, by using whatever information he wants to use to sort it for you. That's what he used to sort. All right. Then the sort values allows you to specify the column you want to use to sort your data set. That's the difference. The dot sort sorts the data set automatically for you, but the sort values allows you to specify what you want to use to sort it. Please, somebody should paste the attendance on the group link for others to also fill. Thank you. Now let's proceed. Now let's as you can see now, I want to sort by age, and I said ascending equals to first. Now when you do these sort values, automatically it is sorted ascending order. That's the default sorting order. But if you want to reverse it, because we only have ascending and descending, if you want to reverse it, just put ascending is equals to false. You don't need to put true again, because it's normally true. All right, ascending is normally true. That's by default. So in order for you to turn it to descending, there's nothing like descending equals to true. Okay, it's only ascending equals to false to revert it. If you say ascending equals to true, it's the same as not even putting it at all, because by default it is sorted in ascending order. But to sort it in descending order, or the reverse of ascending, you say ascending equals to false. But you must look at the comma there. Please don't forget, because if you omit anything, if you omit anything, even if it's dot, you omit in your code when you are performing something, you have an error. So let's run this. Let's sort it. Run it. So as you can see, it has sorted our information. Now it's sorted by the age, descending order. So 70 is at the top. We have 56, 50, 48, 40, 32. All right. So that's how it sorts for us. Now you can say, okay, new df dot sort. Let's do new df dot sort now. Let's do new df dot sort. New df1 dot sort. Just put bracket. Let's run this. Let's see what we get. Now you can see dot sort index. There's dot sort index. So scroll down, scroll down. I know you have an error. Don't worry, scroll down, scroll down. Yes, it has no attribute dot sort. Dot sort index. That's what you're going to put there. Sorry. Dot sort index. Yeah. No, now. Stop moving fast. Dot sort index. Now, when you are sorting with index, it sorts automatically. So underscore index. Dot sort underscore index. Index, yeah. Index. So now, wait. I said wait now. It has sorted by the index number. All right. Now, the sorting by the index number now is sorting alphabetical order. All right. So that's how you sort automatically. Then use this to sort values. Okay. So it's sorting by index. So Alice, Bob, Charlie is what is flowing after the 0, 1, 2, 3. That's why you're seeing is there. But when you use the sort values, it ignores the index number. All right, so you can also specify your axis, your in place, and whatever you want to specify in the sort index, because you're working with index numbers. So whichever way you want to sort it, either you want to sort by salary, by city, use the sort values, because most of us we use sort values a lot, because it allows us to define our outcome or what we want. So let's move ahead. Scroll down. Let's continue. Now you can group. There's grouping in pandas as well. You can group and aggregate. Now, this allows you to analyze and explore your data in a well concise manner. Okay. Now, how do you group? You can group to calculate, or just group to see. All right. You can group to calculate or group to see. Now, how do you group initially? You call the dot group by. Now, when you call the dot group by, it's expecting two key arguments or two key parameters to be passed. All right. So it needs the columns you want to group with. This is like you indexing and doing multiple indexing, right? Doing multiple selection of columns. But the group banner allows you to perform a calculation when you group. Okay, it allows you to perform a calculation when you group. Let's say you want to see the average salary, the average this, the average that. That's how you group. Maybe by city, by age, or by name, whatever. You use group by. So I call it the new df1 dot group by. Now, all these things does not affect your data frame. And all those operations we are performing does not affect your data frame. So if you want to get the result separately, please, you can try to assign it to a new variable. But let's continue without assigning. So new df1 dot group by. Mr. Moses, we are not seeing your screen, please. Mr. Moses, are you with us? Sorry, guys. Let me confirm what's wrong with him. Mr. Moses, are you with us? I think his network has stopped him from sharing. Okay. Let us give him some minutes to come back and then we'll continue with our class.
I'm in class already, sir.
All right, please share your screen. Okay, thank you very much. So I hope we all can see his screen as well. Can we all see his screen? All right, thank you, thank you, thank you, thank you. So let's proceed. Now, it allows you to, the group allows you to group by specifying the key, that is the columns you want to group with and get your output or your result. So here now, I'm using new df1, please, new df1 dot group by, which is the method to group, dot group by. I'm grouping by city and salary, and I want to get the mean of the salary. Now, the operation at the end is performed on the last column. As you can see there, look at the way I arranged my text. I put the city in a round bracket because that's the bracket associated with the group by, which has the first argument. Then the next one is the index, which I want, like the second column I want to group with. We get it, then dot mean. So let's run it. So as you can see, it's giving us the city. The city now is now the index, and it's giving us the salary. Please, we can decide to reset index and do in place equals to true by putting 0 and 1 and others in this place. It looks like a data frame too. You can do that if you want to, but we'll practice with it when we are analyzing a full-blown data set, so we understand it better. Okay, so that's how you do that. So let's move down. So you can aggregate you can do multiple functions. So by aggregating, so let's try this other one. Aggregate using multiple function, new df1. So let's use new df1 dot group by. So I'm calling the city and I'm aggregating. I'm using the dot aggregate method. So inside the aggregate, I'm passing age. I said get me the mean of age and get me the sum of salary. That's what I'm telling you to do. So let's run it. New df1, please. New df1. You use new df. I know we created new df, but always let's work with what new df1. Let's work with what we have been using. New df1. We have added one. So it's still the same thing it's going to give us. Now we are passing multiple functions in it. We are getting the mean of the age, and we are getting the sum of all the salaries. Okay. So I know the value seems not to be changing. Don't get confused. Okay, don't get confused because these values are just one. It's small. That's why you're not seeing lots of changes. Okay, that's why you're not seeing lots of changes because it's only calculating just for one individual information. if this city now has been was duplicated, like we have different persons from the same city, you see the values change. But because this city are just there with one person each, that's why you're seeing single uh information like the original, like nothing is changing. But the age you are seeing dot zero in all of them. So the mean adds all the adds all the columns and divide by the total number. So that is all the similar items when it comes to data frame. So it takes the city of Boston and everywhere it sees Boston City, it adds all of them together and divide by the total number of Boston City. That's how you can perform the mean. So it works per information depending on what you group by do. You can also use by age and whatever. But that's no problem about that. All right. So next step is let's learn about cleaning data and casting data types or handling missing values. Now, this is very important because this is the process of data cleaning. I know we'll be doing some operations on our data frame, but we need to learn how to handle and clean our data very well. So, um, the first thing now, let's check for missing values for each columns. Now, how do you check for missing values? We have, hold on. We have two methods. All right. We have the is null and the is NA. Okay, we have the is null and the is NA method, ways of checking for missing items. Now, the is null, as you can see, there's a dot sum attached to it, which is telling the program to add all. I want to see the total number of missing columns I have. So if we say let's check now, I know we will get 0 because there's no missing, but let's check. Let's run the is null first. Is null. I said is null. Thank you. So let's run the is null. Just run it. You don't necessarily need to change. It does not affect your information, so you don't necessarily need to change it. But it's always good to make a copy. So as you can see, it's telling us 0 because this we are telling to sum it. That's why we did this. Now it's bringing out all the columns we have and showing us 0 because there's no missing values in it. All right. Now this is effective when we have a large data set we are trying to check. All right. Now the difference between is not and is NA. All right. Now there is no, I add a dot sum. Now this any, I'm putting a dot values dot any. I'm simply telling the program that check if there is any missing values. Is there any missing values? Yes or no? Now you tell you true or false. So when it says true, it means there are missing values. When it says false, it means there are no missing values. That's why you see false in the dot is any method. Okay, that is any method. Then we're having putting dot values dot any. So we are checking the values and all of the values if there's any missing items. Like I said, remember when we added that new column. So let's put new df. Use new, just to see if that our new df when we added that column. I know we dropped the column, so it won't be there anymore. We dropped it, so it's not going to show us there. So put it on new df1. I know it will show us if there's a missing item because we dropped it already. Yeah. Okay. Yes. Yes. There is. So there is because I think it's still showing. That's why we are seeing true. Now you're seeing the difference now because we added that value that had a missing item NaN. That's why you're seeing what true. Now if you use this one, I use dot some watch. I think you're gonna get we will get one. Let's run it. Let's run it. Scroll down. Yes, new column has one, as you can see. Look at it. New column has one because when we added that new column, there was one missing item we forgot to include when we added that new row. I mean, so the new column was there. I forgot to include it on it. So that's why I see we're having one. Okay. So when you sum, you have one. When there's any missing value, you see true or false. When you use dot is NA dot values dot any. It gives you either yes or no, true or false. So when you see true, it means there's missing value. Then you now use the dot sum to go and check how many missing values you have. Okay, that's how the process works, guys. So let's move ahead. Now, how do you fill in missing values? How do you fill in missing values? You can decide to drop, you can decide to fill. All right. We are not running this, but I think we should drop. We are dropping this, but we are not running. We are not filling anything. Now, how do you fill missing values? You can fill missing values with any given item you want. All right. Now, let's say we have missing values. I know I don't want us to fill it. I want us to drop that one, so you see it as left. Now, to fill a missing value, any empty value, you can fill it with a given number of your choice. You can fill it with something. Mostly people fill it with 0 because so that we won't, like when we are working with a company's data set and we don't want to uh remove the number of employees we have. There might be somebody that is not let me say when they are putting these values, we had issues on it and want to just fill it and carry on with the process so that it will not affect us while we are computing. We can decide to put a 0 on it so that even when you calculate, you won't get any change. So that's why I say df.fill NA. That means fill anywhere you see NA with 0. Fill it with what? 0. You can say fill it with 1, fill it with 2 or whatever. But we said fill it with what? 0. Alright? Then to drop, we call the .drop NA method. Now, .drop NA means drop anywhere you see NA. Now when you are dropping, you drop the entire row. That entire information of that person is being dropped. So let's run the .drop null values. Let's run it. No, .drop. Yes, let's run it for new df1. Yeah, let's drop this. Now, scroll down. As you can see, it has dropped that column that had NaN. It's no longer there. All right. So that's how you drop. Now, when you drop, it affects your data set. Don't forget. Okay. It affects. All right. So next thing, we can change data type of a column. Let's say we had a data type, a column that has a data type we didn't like. You can change it. You can change it from whichever data type it was. You can change it to the one we want to change it with. Let's say we had a date time that was seen as an object. But first of all, let's check the data type. Please run df_age.dtypes. Use new df1, please. New df1. .dtypes. .dtypes. That's what I said. Run it first. New df1. New df1 .dtypes. .dtypes. Yeah, that's how you check for the data type. So let's run it. Scroll down until you see your error. So always watch out for it. Remove that bracket. You don't need that bracket. Thank you. Now, as you can see, we are seeing object, int, float. All right. Object, int, float. Now, we can decide to change any of these data type though, but mostly we change data type that involves that are unique, that are different. Objects, like I told you guys in the last class, object data types are both a string, integer, whatever. But the compiler segregates and separates integers and floats from objects because these integers and floats are what you can perform numerical analysis on. Right? That's what you can perform any numerical analysis on. So if you are trying to perform analysis on objects, you get an error. It only works on integers and floats. Okay. Then let's say we have a date time data type here. We can convert that. All right. So how do you convert? Easily. Now, if you scroll up, please scroll up. You can see where we changed it. I'm not going to run it. Don't worry. Df age. We call the column age. and then we reassign the age, which we have changed the as type to what? Int. The dot as type is what we used to change. Okay, the dot as type is what we used to change to int or to float or to whatever. Let's say the type was not changed initially. This is how you change it. So let's move down. So I think there are some things we are going to like if I'm not almost done, there's some things we need to stop and practice more. All right, so I think I've explained. Hold on, stop. I've explained all this. The dot, okay, yeah, the dot describe method. Now, these are for data exploratory when you're exploring your data. Now we have the dot describe. Right, the dot describe shows you all the statistical analysis of your data frame. So let's run the dot describe method. We'll just run this. We'll be fast about this. The describe method. So it shows you statistical analysis of all. As you can see, you're saying count, mean, standard, mean, 25%, 50%, 75%, max, and whatever. So this is what it shows you. This is like a statistical description of your data frame. That's what the dot describe does. So the next one is dot shape. We already know what dot shape is, so let's run it. We already know what dot shape is. All right, thank you. So let's continue. Now the next one is dot columns. Now dot columns gives you the name list of all your columns you have. So let's run columns. It gives you the list of all the columns you have: name, age, city, salary. As you can see, it's telling us object as the type. Dot info. Dot info gives you both the data type, the name of your columns, the number of rows, the number of columns, everything. That's what dot info gives you. All the information of your data set is what dot info gives you. So let's run it. All right, that's what you, as you can see, we are having, yes, this is the whole info. We are having, hold on, we are having the kind of file we are working as, which is a data frame. Then we are having the range index, 5 entries, 0 to 4. We are having the columns, total number of 4 columns. Then the columns and the index were listed out. Then we have the data type. As you can see, there's a null count to show you if there's any empty values. So null count as we counted, 555, they are complete. So if you see that maybe one is 5, the other one is 4, that means there's a missing value there. And the data type is also specified. Then at the bottom, we have a summary of everything, showing us that, oh, we have two integer data type rows, and we have two object data type rows. So it also shows us the memory usage and all that. So that's what the dot info does. So let's scroll down. I think the next one is date types. We already know what date types is. Okay, so all right, hold on. Now this is a date time. If you are working with date time table, but I don't want us to, let's not bore ourselves with this. So if you are working with date time table, you can import the date time and use it on your program. Import it along while importing the the pandas as well. But we won't bore ourselves with this because most of our information we are working with, or we'll be working with, we have a date, we'll have dates attached to it and time. So we know how to import these, all these, and then we'll use them. Okay, but let's stop here and take in questions. So if you have questions, please raise your hands and we'll call and I'll attend to your questions. I might not necessarily say everybody, but please raise your hands and we'll use the few minutes we have to attend to all the questions you guys might have regarding what we've learned so far. So if you have questions, please raise your hands and I will call. So please, if there's no hands raised in the next 5 minutes, we'll call it a night. We'll end the class and call it a night. And the question? Okay, I have just Victor raising up his hand. So Victor, what's your questions? You can unmute your mic. What's the question?
Okay. Good evening.
Good evening.
Okay, thank you. very much for the class. I really appreciate. But I want to know on
Yeah.
the data type, what is the difference between object and string?
There's no difference. Strings are regarded as objects. Were you in our last class when I explained NumPy?
No, maybe you are at the beginning. I wasn't, but I was in the class.
So when we explained it, yeah, don't worry. When we explained, we said every information on Python is an object. That's what I said just now. I said every information you see on Python is an object. Like integers, floats, strings, booleans, they are objects. All right. That's why we heard the term object oriented programming, OOP. All right. That's why we sometimes we do hear that term. Most people will hear it if you don't understand what it means. It means they are working with objects, whether they are integers, floats, strings, booleans, and the likes. They are all objects. But I told you that the program, the compiler only separates integer numbers and float numbers because these are numerical values so that you can perform analysis. But strings are objects. All right. True or false, you see Boolean. You won't see Boolean here. If there's a data type that has true or false, you won't see it as Boolean. You will see it as objects because you cannot perform numerical whatever on it. So that's why it's always objects. All right. So there's no difference between strings and objects. Strings are objects. They are the same. I hope I've answered your question. Mr. Victor, I said I hope I've
I
answered your
say yes,
question.
sir. Thank you, sir.
All right, you're welcome.
The
Please, this will be the last time I say. When I ask a question, when I say, "Is there any question?" Please raise your hand because I don't like entertaining questions when I'm done with questions. So please, Mr. Abiodi, what is your question for the last time? If you have any questions, raise your hand. When I'm done answering those questions, I won't take questions again. So over
So
to you,
sorry,
Abiodi.
sir. Apologies for that, sir. Please, sir, I just want you to please kindly help us just do a kind of a brief recap of like all the pandas and the data frame we've done. Like just to
I should do a
grab it in.
recap.
Yeah,
We
just
don't have much time for recap, guys. Don't have much time for recap. So don't worry about recap. The recording will be sent. The recording of last class and this class will be forwarded to you so you guys can watch them again. If you say I should do recap now, this is 9:42 and I will have to take you guys almost an hour to do recap. So I don't want to all right.
honest.
All right, so please fill your attendance for the class has come to an end. So thank you guys for joining, and please fill your attendance. And some persons will be leaving. Some persons will be leaving our group very soon. But when I let me just give a little grace. Some persons will be who have not fulfilled the criteria will be evicted from your cohort. So we'll know the number of persons we are working. As you can see, the number of participants in this class has been deteriorating a bit. All right, but let's not lose hope yet. Okay, so good night, guys, and have a beautiful night rest. So thank you, Mr. Moses, for assisting with the class and sharing your screen. And do have a lovely day. See you guys in our next class. Good night, everybody.
All right, good night, sir.
Good night. Night night.
Thank you. Thank you. Good night.
Mr. Moses, you can stop sharing your screen now.